Our next speaker is the Dean of Research with SANS. He's a senior instructor with SANS. He also directs the Internet Storm Center. He founded DShield, which is now part of Internet Storm Center, as I understand. He has a podcast. He has a blog. He has numerous publications. He's been honored by SC Magazine, by Network World Magazine. He's a innovative, cutting-edge researcher. He's a thought leader. I'm very, very pleased to welcome Johannes Ullrich.
Thank you very much for the great introduction. So I can skip right over the introductory slide here, introducing myself. Just want to add to it, I'm actually from Jacksonville, a little bit up the road here, sometimes referred to as Florida, but southern Georgia, if you're familiar with the area. Anyway, so let me get started right away here. Anybody here using NoSQL databases right now in your environment? Okay, who is using NoSQL and SQL databases? Okay, I think I see about the same number of hands going up here. You mentioned the Internet Storm Center. I just want to introduce this very little bit because some of the work I'm presenting here is based on it. And it's not really just my work. That would really be dishonest to say that. A good contribution here came from Bojan. Bojan is one of our handlers. He lives in Croatia. He's doing a lot of pen testing. And towards the end, I'll talk a little bit about sort of complex data types, how they can be abused when it comes to NoSQL databases. And this work is really sort of mostly his work I'm presenting here. Now, when we talk about NoSQL, what does it mean? I think the one thing everybody can agree on that NoSQL means just that, everything but SQL databases. I'll talk really about two aspects of NoSQL security, and some of it sort of comes with the simplicity of these databases. The reason people like NoSQL databases, they're simpler, they're faster, they're more agile than a lot of these more traditional SQL databases, and that sometimes comes at a cost, this speed. So no more joins. Well, that's not really a security issue. That may be a security advantage if you can write simpler queries, and often it turns out to be a security advantage that the queries are simpler. But when we talk about simpler storage engines, well, a simple means also less control in many ways. And of course, that's sort of where security hits us. Now, it covers a very wide range, like I said, when we talk about NoSQL. I'll go over some of the basic NoSQL databases that sort of I worked with over the years and that I've investigated for this. But keep in mind that really a lot of this is true for databases I may not explicitly point out here in this talk. Like we have a worldwide range here. For example, one that I sort of removed for this talk because I don't really see it as a database, Hadoop. Anybody using Hadoop? Nobody using Hadoop? Yeah? Is it a database or not? Yeah? I call it a file system, a distributed file system. Some people call it a database. And that's really sort of the problem. That's really sort of a ranging scale of systems that we have. Now, what I looked at is how well do these databases support your basic security controls, authentication, access control, how do we encrypt data in transit? Is there any chance to encrypt it sort of in the database at rest? So that's another big part here. And in the end, if stuff happens, you want to know what happened. So what kind of logs do we get out of these databases? And they're certainly attacked quite a bit. Here is statistics from Shodan. All familiar with Shodan, that sort of scans your networks and finds all the vulnerable systems. They found 100,000 exposed Memcached databases out there that are ready for the taking. And they are being taken. This was a big compromise. Not sure if anybody remembers that. These little toys that you buy for your kids because you don't like to talk to them, so you buy them like a little toy to talk to your kids. And here database was compromised that actually stored all the voice snippets that these teddy bears in this case recorded, Mongo DB here. And this was ransomware. We all know ransomware from desktops. Well, it goes after database as well. And of course, in this case, they don't encrypt your data. They just delete it and then claim they encrypt it and sell you that encryption key. So a little bit variation on that ransomware theme. And yeah, this was the one that just happened last week. Exposed Elasticsearch servers, and they were actually mostly in Amazon's cloud, were used for botnet command and control. So these databases are attacked all the time. And just to bring that message home a little bit, when I set up my computer, I set up a little honeypot on sort of 3 very common ports. First one, Elasticsearch. Well, we already got some requests here, some HTTP requests. The second one, 1122, that's memcached. So already got 2 stats requests here. And then the last one, MongoDB. It looks like we got sort of 2 requests coming in here. And this was like within the 15 minutes that I set up a laptop here on sort of our HoneyNet infrastructure. So they're being hit. Now, let's start with Elasticsearch. Elasticsearch is a cool database if you try to write a web application because it provides that really simple REST JSON interface. So JavaScript is really built to the right little search clients or clients for Elasticsearch. It also used to add a very popular and very powerful scripting language, Groovy. Groovy had one small problem. It was so powerful, you couldn't really constrain it very well. They tried to put in a sandbox, didn't work, because you could break out of the sandbox if you used the right Groovy command. And in this case, for example, you could execute arbitrary shell commands. Groovy pretty much has been removed, so that ability just ripped it out. They were talking about putting something as a replacement, like they have Lucene, the other scripting language, not quite as powerful. And you know, as a developer, you always want power, security. That's someone else's problem. But anyway, yeah, in older versions, when it's still enabled, you can disable the feature. But like I said, in current versions, it has really just been removed. Now, Elasticsearch actually has a document that tells you what to do, sort of as best practices. Only have it listed on loopback. Great idea until you try to put it in the cloud and try to remote connect to it, and then all of that really doesn't work all that well anymore. So there was one problem. You can enable SSL, and you have one advantage with Elasticsearch because it is all HTTP. You can just put an HTTP proxy in front of it and have it do filtering, authentication, all of that good stuff. So that's sort of one way to retrofit security a little bit. Yes, it's certainly being scanned. You just saw my honeypot results. This is data that we collect sort of with our honeypots and such. This sort of per day, we have about, this is the number of source IPs that are scanning each day for Elasticsearch. It's around 1,000 sort of that we detect each day. And this is last month's data. So Elasticsearch out of the box, security, not so much. A lot of the security you have to enable, you have to add it later with a proxy. Particularly if you want something a little bit more fine-grained access control, you're probably left to doing that with a proxy. And then, of course, it can get a little bit tricky. Your proxy isn't really going to parse the query. So how do you identify users? How do you identify privileges there? Not as you're used to with SQL, where I can define for each row who has exactly access to. Now, MongoDB was the other one that I had up here, and the other database that we had already a couple of hits for. I'll come back to MongoDB later, but in some ways I find it very similar to Elasticsearch. It's also a JSON object I'm storing in the database, very sort of HTTP-based, the database, the way it works. It actually does have row-based access control, so that's a big plus. And you usually do not find this in these NoSQL databases. You have to enable it, but then again, your role-based access control usually have to enable it. They can't enable that for you necessarily. Also, make sure, and it's another sort of thing that's really important for all of these databases, run the latest version. It's not just security bugs, it's security features that were added over the years to it. And while you're running the latest version, I know I'm a developer, and we all know developers here. they know everything, so they never read the manual. So read the manual and how to configure all of this, including some of the security guidance that these databases offer to users. Now, there's even some encryption that you sort of build in a database. So that's actually not bad. That's even a lot of SQL databases struggle with sort of doing effective and proper encryption at rest. Yes, they have a local key file, but it does actually integrated key management and all the good stuff that you really expect from sort of solid encryption at rest. But remember, you need to run the latest version. Same for logs. Now, MongoDB is almost no longer a NoSQL database. It has way too many features for that when it comes to security. But yes, they now even added logs. Just like all of these logs are typically not encrypted. So be careful what you log when you're worried about that. But at least you have that log to see what really happened. And just like Elasticsearch, MongoDB, probably the same 1,000 hosts that are scanning for that. They're trying to find your servers here. So here's a quick summary. Really, as far as NoSQL databases go, MongoDB is probably the one that sort of has the most security features. You have to enable them all, but that's part of life. And that's not really that special. Yeah, Hadoop, like I said, don't really want to talk much about this because it really sort of spreads, it goes beyond the scope here a little bit when it comes to it. But the problem from a security point of view is here again that this very simple HTTP REST access. Now we all like REST web services. They're simple, they're easy, they're fast, but cross-site request forging. One HTTP request to a Hadoop database cluster can really be very catastrophic. So be careful how you filter, be careful you do authentication to it. And Hadoop, sort of as really more of a file system, has more of those controls built in. So not that bad, really. Well, okay, so which ones are not that great? Well, got one database here, Memcached. Now, Memcached really focuses on speed. It's all in memory. That's sort of the idea. So the entire database lives in memory, very simple key value lookups. Absolutely no access control there. And then you have to figure out what data do you store in that database. Session IDs and things like this, okay, only the web server needs to have access to. I don't really need a lot of sort of fine-grained access control for something like this. Conventional data, social security numbers, credit card numbers, maybe not so much for it. And then again, based on it being in memory, it's really more sort of a non-persistent database anyway. So I think that removes the risk somewhat here. Where this becomes really interesting is, yes, you should restrict access to localhost, but one of the great features of Memcached is that you sort of can spread it out, you can build clusters that requires network connectivity. So with that, the network access is required in some ways. If you do move it out into the cloud, then of course you no longer may have control over that network as you're used to. There's a very close cousin to Memcached, Redis. Redis actually in their security notes describes that this database is designed to be run in trusted environment between trusted clients and trust servers. Well, anybody who has a network you trust, so you haven't really looked close enough probably why to trust or not to trust it. This really much is valid for here. So really the only security we have here in Memcached is simple sort of password-based authentication here, but no roles. It's just one user to authenticate for it, and that's it. And once there is access to the database, then of course it is almost sort of a little bit, a game over for you. But anyway, let's just see how many more people did we have got in here. I think we got 2 more stats requests here. Sadly, they never sent sort of a Elasticsearch request here, and I don't reply with anything. But you do see we have now 1, 2, 3, 4 requests to our sort of Elasticsearch listener. These things are continuously attacked. That's really sort of one of the big problems here. So how do we secure it? I'm not big into just breaking stuff. I also want to know, how to fix it. And a couple things, I already mentioned that. Use the latest version. Like I said, not just because there's some security vulnerabilities that happened over the years that are fixed in the latest version. You want to have the latest major version, not just sort of the security fix, because it gives you more control. It typically gives you more features related to security. There's something over the last 2 years, all of these databases have added quite a bit more features, so this is certainly a substantial change that happened. And when you're writing your code, just don't expect that a database does a lot of what you're used to when you're sort of used to writing SQL code. And when you're writing stored procedures, a lot, a couple of you. Like there's very nice things that you can do in traditional SQL, stored procedures for access control. You can sort of in your stored procedure check what user is being used, and then do all of the stored procedures, centralize it that way. Real great things that you can do, not in NoSQL. In NoSQL, you typically don't even have different users as far as database is concerned. So this really puts a more weight on the code. Now, when we talk about NoSQL applications, a lot of the times we're talking about these newer interactive applications where more of that code is actually residing on our client, not necessarily even on the server. So like the client connecting to the database without even going through any server-side code. JavaScript creating those REST queries that are then being directly sent to Elasticsearch or MongoDB. So now you're even more tempted to do client-side authentication, which always works great until the first incident. But so yeah, you don't have that access control available. Never ever expose one of these NoSQL databases to the network, to the public network. And I put in parentheses, not a great idea for traditional SQL queries either. And a lot of the attacks that I showed earlier when it comes to NoSQL databases, they happen against standard SQL databases as well. Like exposed MySQL servers getting encrypted. Happens all the time, or data being leaked and such. That certainly happens. So do not expose them on the public network. The big threat here is that your incentive to actually doing that increased. Because now you want the client to connect directly to that database. You never really do that with a SQL database. You have to try really hard to do that. Here it's now sort of standard operating procedure to have the client, JavaScript on the client, send queries directly back to the database, which of course requires it being exposed. Yeah, and then the authentication mechanisms, figure out what works there. It's just simple password. Can you do SSL certificates or whatever? So again, see what works. So typically not the same way we have it now. There's one way where SQL sort of sounds, NoSQL sounds a bit different. What about SQL injection? Now, we all know we write prepared statements. SQL injection isn't really a problem anymore, other than for applications we wrote last year. But what about with NoSQL injection? Well, let's think about it. The problem with SQL injection is that we mix user data and code. You have these select statements that's from and the queries, and then you insert some user data in here that can rewrite the query. Can we do the same thing with NoSQL? And the answer is maybe sometimes yes, it works. It depends. What we have with NoSQL that you don't really have so much with normal SQL is these complex data types like JSON. Anybody was here in this room before lunch? They had a real great talk about sort of deserializing JSON and such. And what did they tell you? Yeah. Don't do it with untrusted data. Yeah. So check your type and make sure it's all done correctly. Well, that's hard, or it's much easier not to do it. So anyway, so NoSQL, they always describe them as key value pairs. So that's not how it's described. But those values are usually fairly complex data types, like JSON is sort of the number one here to really worry about. And parsing JSON and deserializing it or serializing it can cause issues. It means I've tried to pull these values out of JSON. Yeah? And why is this hard? Well, again, we have a very complex data type. I know I'm committing a little bit blasphemy here, but JSON is really no different than XML. It's these complex nested data types, and I don't think anybody really has figured out how to properly parse those type of data types. Whenever they happen, we have a hard time figuring out, how are they delimited. Yes, here I put nice double quotes around it, but we may have single quotes. How is now data being pulled from the user and inserted into a JSON object like that? That's where problems, very simple problems, really happen. We're not necessarily talking here about super complex stuff. So, for example, here, if I'm inserting JSON objects like this, if I'm inserting stuff like this blindly into my MongoDB Elasticsearch, it doesn't really care. It's not like in SQL where I have to have the right number of columns. I can just throw data at it and it'll slurp it up. Now, at the minimum, I'll just fill up the database with garbage, which at first, may not really do much damage. But when your query language is also sort of based on JSON, then again, we're back to mixing up code and data. So in this case, the JSON encoding, we're mixing it into code. And here's sort of a little example, and this is sort of the real-world application is one that Boyan ran into in a pen test here. This is sort of your standard MongoDB query. Now, this was a mean, so mean that acronym refers to MongoDB, Express.js, AngularJS, Node.js. It's one of these applications to get like a little hello world. You have to download 20 megabytes of code, and then it does something. But anyway, this is sort of what the query looked like. So we're going to get all products for which we have a quantity of greater than 25. And you already noticed how this is sort of JSON. Our query parameters now become JSON. So that's really where bad stuff happens. So in this particular case, so the little code here, a little code snippet. So there was this ID was being passed as a parameter. Developer expected a number. So here we just create that query out of that particular ID. So just your standard JSON parse, and this friendly parameter is what's a search parameter here. We just add that user supplied parameter. And then we use this JSON snippet in our standard sort of MongoDB query here. So find one, return the first match. Here's our query, and then launch this function whenever it works. So that's very simple, very standard sort of MongoDB sort of JavaScript code. How do you exploit it? Well, what we are passing to the database now is no longer just a number. Instead, we're passing sort of a query snippet. Doesn't it look just like SQL injection? Yeah, the characters look a little bit different, but really the logic behind it is just the same as SQL injection. And what we end up with now in our query, we'll go just back here. So that parameter here is now that not equal null. So this becomes now the search parameter here, because now friendly, and then square brackets not equal null. So, okay. Hey, return me everything where friendly is not null. That's really sort of what we're ending up with here. And this worked in this case. So we're really back into SQL injection territory here, with some of these applications. The problem with this is a little bit from a security testing point of view. Your standard vulnerability scan looks for SQL injection will not necessarily find this. If you're lucky, you get an error message. So, if you do the quotes and such, so at least to tell you that there may be a problem. But it's probably not going to recognize the response if there is a response, like if there's an error message coming back. And that's sort of where some of your security then fails. Now this was specifically with MongoDB. Elasticsearch, I could imagine very similar scenarios. That looks really just sort of very much alike. The query language is a little bit different. There is Lucene language that Elasticsearch likes. But again, I can pass JSON objects and they're being parsed by the database. In addition, of course, these REST APIs. Well, we all know cross-site scripting and cross-site request forging is sort of that very deadly combination. Let's just assume for a moment, go to your happy place. No, we don't have cross-site scripting in our website. But we still have to be worried about these cross-origin requests. Modern browsers, they will send the request. They don't take the response, but they will send the request cross-origin. So if you didn't add your custom header to make that pre-flight, or if you don't sort of have some handshake there with some validation cookie to make sure that this was an authorized cross-origin request, then you may have problems again. So, all of the good JavaScript functions that we need, for these applications to work, they can now be used against you. And it's really up to the browser to see what works and what doesn't work, which of course means that once there's a bug in the browser that doesn't do the same origin policy correctly, your site may be vulnerable if you're allowing these requests. And I'm not sure if anybody ever looked at browsers, how well they implement different cross-origin standards. I wrote a sort of a test page for that, and I found it's mixed what you find, particularly what headers you can add and not add. Specification is one thing. What's actually being implemented in real life with browsers is another thing. Could probably do a whole different talk about that part. Yeah, and then of course sending these queries directly to the browser. So really the database now, because it does accept HTTP, really acts a lot more than a web application. And that's why we sort of almost cut out the middleman here. That's why we have all of our code in JavaScript on the browser and then have it connect directly back to the database. Because the database really sort of acts like a web application, a web server. And that sort of entices us to write these particular applications. Of course, in a good old traditional web application or a firewall, our web application firewall could restrict ours to get, post, head. No, MongoDB, you better allow delete, because you need that in order to send delete requests to the database as an HTTP request. So really, really tricky how you also set up web application firewalls that connect when your client connects directly back to these web servers. Now, there are a couple things here. So for example, Elasticsearch. Elasticsearch, you can enable these headers, but again, you have to do it. You have to set your origins correctly. By default, it actually sets it to asterisk, if I remember correctly. The problem here I see sort of in real life. You're a developer, you develop your application, you set up all these headers correctly, or a sysadmin does that for you, then you move it live, and then all of your host names change and stuff like this, and it no longer works. Returning it to the asterisk, to the wildcard, is the simple fix to make it work. So that's sort of one reason why you have that. Yeah, and here is sort of another little example. When you do the simple post request, that's sort of how you would then write the query. I have sort of the do something evil with the data, where the attacker now can insert arbitrary data, deposit on a web page, and then have the request sent. Like I said, the request will be sent. You may not get the response back with cross-origin restrictions, but the request is typically still sent. So if you're not careful there, you do have problems. So other methods, well, hard to avoid them. Good old web application firewalling was so much easier. And even anybody ever had to maintain a web application firewall? Was it easy? Not really. It just got harder, kind of if you do it for that. So yeah, and the REST request back to something like Elasticsearch and MongoDB certainly can make it more difficult for you. So quick conclusion here to give us enough time for some questions as well. RTFM, read-define manual. Like I said, it's important because this stuff keeps changing and they keep adding more controls. Like I said, make sure you set those course headers correctly to prevent some of these sort of simple one-click attacks and such to make that work for you. Default configurations are never sufficient from a security point of view, so you definitely want to improve on that. And like I said, it's not something NoSQL specific. Network access, and this gets really tricky. Like if you do expose database to the user, if you have one of those applications, at the very least put a proxy in there. Yes, it will delay your application response a little bit. Yes, it adds latency. Get a fast proxy, it's not that bad. To do a little bit more filtering there. Authentication, again, it doesn't really help you if the client connects directly back. Because then you have to give the credentials to the client, which, they're keeping it secret, they'll promise. Put in your EULA, then they won't leak them. And look at the logs. I am a big fan of logs. I look at logs all the time, but I know it can be boring. If looking at your logs is boring, then you're not looking hard enough. There's always something interesting in there. So definitely do that. And when you're doing a code review, that entire process of how are you dealing with this complex data? Which APIs are you using to parse it? How do you configure that? That's the hard part. Focus on that. There aren't really sort of any simple workarounds that I've seen for that. Design your application to only accept easy data. That would be nice. My application only accepts numbers. That usually doesn't work, but if you can, also application design can help quite a bit. So anyway, I think we still have sort of 10 minutes for questions or so. So any questions? Yes, sir.
Is there any effort out there for parameterized query equivalents? Any equivalents for NoSQL parameterized query, protections? Like, for instance, it seems like in the examples you showed, it all comes down to the same issue, key and value, and whether those two ever are allowed to touch each other in the code, right?
Yeah.
So if the inputs, even if it was hierarchical, without knowing the structure of whatever data type it is, had some type of generic dictionary only allowed, that the dictionary can include other dictionaries as values, that's fine, but it only allowed that separation always of key and value for the values being provided, that might help for a parameterized query.
Yes, and I think you're sort of on a good track there. So the question here was, is there something like parameterized queries for NoSQL? Because that saves our bacon when it comes to SQL, parameterized queries. Nobody got rid of SQL injection until we sort of did the parameterized queries. For NoSQL, I haven't really seen anything like that. The problem I find is that you're passing these JSON objects back there, like in MongoDB. And then it again depends on the database, but and the query itself is also a JSON object. And I think that's sort of where the problem comes in. I'm not sure anybody's seen anything that's parameterized queries for like Mongo or Elasticsearch. Just for the audience in case, because again, listen out for it, ask for it. Maybe someone will come up with one, because that's really what we need. We need something like parameterized queries for that. Now you can still help us a little bit by like validating your input before you send it to the database, but that's hard. Let's say you have complex JSON objects that include JSON objects because you want to sort of move those complex objects around, that's when the problems happen.